Hey guys, Mrs. O'Donnell here. Today we're going to be solving quadratic equations by graphing. Okay, our goal is to solve quadratic equations by graphing. This week we have a packed week. We've got a ton of stuff to work on. Thankfully, properties of radicals should really be reviewed. We've already touched on this some this school year, but you know it's a great review to have. It's always good to bring those key topics back. Now, if you're struggling, I want to encourage you to make sure that you're coming to my optional office hours. It is an event in your Google Calendar, and if you haven't already, the Google Meet app is awesome on your phone. So even if you're going to be out and about, and maybe you're in the car driving somewhere, you're not driving, I'm assuming someone else is driving, you can hop on and you can ask me some questions during those times. All right, so last week, let's refresh. What did we learn about last week? So last week we talked about special features of quadratic graphs. Okay, for example, the minimum, if a graph has a minimum or a maximum, which is also known as the vertex, right? Or we talked about that axis of symmetry, which kind of chops our graph in half going through. It's that imaginary line that goes through the vertex. This one is at x equals -1. Okay. We talked about what that leading coefficient does. So here we have a +1. That positive a value means that we have a parabola that's opening up. If we haven't had a negative leading coefficient, our parabola would open down instead. We also talked about the three forms of quadratic functions, right? We talked about standard form, which is ax squared plus bx plus c is equal to 0. We talked about vertex form, which is a times x minus h squared plus k equals 0. And we talked about factored form, which shows us our factors: x minus x1, x minus x2 equals 0, right? And we talked about, the special, and there's an a here as well. We talked about all of the special characteristics that you can see very quickly from each form, right? Right now would be a really great opportunity for you to pause the video and challenge yourself to recall what key characteristics you can quickly see from the equations in standard form, vertex form, and factored form. All right, so for you unpausing, or for those of you who didn't pause at all, hopefully you remembered that in standard form, we quickly see that y-intercept, which is that c value. In vertex form, we can very quickly see the vertex of our function, which is at hk, the coordinate pair hk. And factored form, we can see those x-intercepts, or the factors, which is that x1 and x2. All right, so moving on, let's talk about solving quadratics by graphing. So to solve a quadratic by graphing, the function needs to be in standard form, set equal to 0. Or it could be in any of our three forms, but our approach to graphing it might be a little different depending on the form. There must be at least two solutions, or there can be at most two solutions to any quadratic function. So if we're looking over here at our x squared plus 2x minus 3 function, we see that our solutions are our x-intercepts. It's where that output is equal to 0, right? If our function is set equal to 0, we have to look at across from where that output, or that y value, is equal to 0, and that's right along that x-axis. Okay, so here we have two solutions. We have a solution at x equals -3, and we have another solution at x equals 1. All right, this next quadratic that you see, this next parabola, has only one solution. Okay, it's actually only crossing our graph right here at x equals 4. Okay, and this last one that you see is actually, this parabola is not touching our x-axis at all. And that means that this has no solutions or 0 solutions. Okay. All right, so when you're graphing, very basic graphing, oftentimes finding the vertex is really helpful. Okay, so I want to talk about how do you find the vertex from each of our different forms. Well, from standard form, it's a little tricky. There's actually a formula that you can use, right? So the formula is x equals, and this is giving you that axis of symmetry, negative b divided by 2a. So whatever number that you have for your a, b, and c, notice standard form is written out in descending order, right? So your coefficient in front of your x squared is always your a. Your coefficient or your number in front of your x is always your b. And then your number that doesn't have an x at all, your constant, that's always your c. Okay, so you would just take those and your b and your a, plug them into this formula, and that would tell you the x coordinate of your vertex. Okay, for vertex form, it's even easier. Your vertex is at the coordinates shown in the form, so it's at h, k. And factored form starts getting a little tricky. I don't know that I think that finding the vertex is the easiest way to graph from factored form, but it's actually not too bad. You take each of your factors, right? So we would have whatever x1 is, you add x2, and then divide by 2. And that, again, is going to give you that x coordinate of your vertex. And then you'd have to go in and plug back in to find the y coordinate. Same thing over here. You have to plug in to your equation to find your y coordinate. All right, so why would we need to find the vertex to be able to help us graph our equation? Well, finding the vertex kind of gives us that starting point, right? Because we know that our parabola is always symmetrical, so that really helps us figure out what kind of values we want to put in our table. All right, so first thing we're going to do here is practice finding that vertex, right? So it looks like my equation is already in standard form. So I know to find my vertex, I'm going to do x equals negative b over 2a. And it looks like a is equal to 1, b is equal to negative 1, and c is equal to negative 2. Remember, your sign always stays with the number. Okay, so I would end up having b is equal to negative 1 divided by 2 times 1. So that gives me 2 negatives make a positive, and 2 times 1 is just 2. All right, so my vertex is going to be at x equals 1/2. Ooh, that's a little tricky here. Okay, remember the other thing, okay, so that kind of helps me know where the position of my quadratic is. The other thing that's really easy for us to see from standard form is that y-intercept, right? So our y-intercept is going to be at 0, -2. All right, and then let's see here. I could, do 1, 2, 3, 4, 5, maybe -1. And now I can just plug and chug through to figure out what the rest of my outputs are. So let's see here. If I plug in -1, I've got -1 squared minus -1 minus 2, right? So -1 squared is 1, plus 1 minus 2. 1 plus 1 is 2. Minus 2 is 0. Okay. And let's see here. If I go ahead and do that again for 1, I'm going to do 1 squared minus 1 minus 2. So 1 squared is 1 minus 1 minus 2. So 1 minus 1 is 0. Minus 2 leaves me with negative 2. Okay. And let's see here. I'm running out of space, so I had to erase. All right, now I'm going to plug in my 2. So I've got, let's see here, 2 squared minus 2 minus 2. 2 squared is 4 minus 2 minus 2. Let's see here. 4 minus 2 is 2. 2 minus 2 is 0. Oh, it looks like I've got another 0. So I actually found right here, if I'm solving, I actually found my 0. Okay, because I was actually just looking for where my output is equal to 0, and I found that right there. I could go ahead and graph some of those points just to double check, right? So let's see here, negative 1, 0 would be here. 0, negative 2, that would be right here. 1, negative 2. 1, negative 2 would be right here. 2, 0 would be right here. And let's see here. Not quite sure what our vertex is, but let's see here. We could plug it in, right? Because we know that our vertex is when x is 1/2. So if I plug that in, I've got 1/2 squared minus 1/2 minus 2. So let's see here. 1/2 squared is 1/4 minus 1/2 minus 2. Well, I know in order to subtract, I have to have a common denominator. Minus 2/4 minus 2. So 1/4 minus 2/4 is negative 1/4 minus 2, which is negative 2 and 1/4. So let's see here. That'd be 1/2, negative 2 and 1/4. So like about right there. And I could, at this point, if I wanted to, I could sketch the graph of my parabola, right? By just connecting my points. And I could also take my solutions that I found and write my parabola or my quadratic in factored form. X plus 1 times x minus 2. Right? We know that that gives me the factored form of that parabola because you can take your roots and plug them back in to your factor pairs. All right, so next I want to try graphing this quadratic x squared plus 7x equals negative 10. I have to find the vertex, but right now I don't have any forms. So the first thing that I need to do is I need to get this into standard form. So I'm going to add 10 to both sides of my equal sign. So I have x squared plus 7x plus 10 equals 0. And let's see here. If I want to find where my vertex is going to be, I'm going to do I'm going to do x equals negative b over 2a. So let's see here. My b is 7, negative 7. My a is 1. So 2 times 1, which is just 2. So negative 7 over 2. So again, not a great number. That's what, negative 3.5 is my vertex. So negative 3.5. Okay, so then maybe to fill in the rest of my table of values, maybe I want to go negative 4, negative 5, negative 6, negative 3, negative 2, negative 1, and kind of see if we get there. Okay, and then I'm just plugging and chugging through, right? So I'm evaluating this equation or this function for these values. Okay, plugging in, seeing what I get. Take a minute, pause the video, try it out. All right, check your answers with my answers. Hopefully you found your answers right here in your table that x is equal to negative 5 and negative 2. Those would be your solutions. And if you really wanted to, you could put this back into factored form. X plus 5 x plus 2 would